In the previous lecture, we discussed about the uh, difference between compiler and interpreter, and we have seen how the compilation takes place. Now, in this session, we are going to discuss about the phases of a compiler. That means, what are the phases inside the compilation process in order to convert the source program into target program. So, previously, we know that. The compilation is nothing but the source conversion, that is compiler accept input in the form of source language and delivers, that is output generated in this target program, that is object code that is to be generated. Now in this lecture we are going to see the what are the, while conversion the source program to object program, what are the phases that is to be involved in the compilation process. The main outcome of this topic is what are the conversions, that is phases to be involved from high level to machine level language implementation. So while implementing, delivering this output of, that is machine level language, some of the phases to be involved. So we are going to take up this as one by phased by manner. First, how many phases that is involved in this one. So let us go to the first, the block diagram, that is the compiler phases. It is also called phases of a compiler or block diagram of a compiler. So here initially we already know the source program, which is written in either of the languages such as C, C++, Java, etc., Python, etc., different languages, and we are going to achieve a target program, that is machine code. Why? Because the computer machine can't understand this target program. So one of the translator is required in order to convert this program, the given program, into a object program. Since users are familiar to write this machine, that is English written statements, human language understandable languages, and this can be passed to the compilation, and compiler will understand, recognize the corresponding statements, and finally giving the output of the compiler, that is machine code, that is to be machine understandable. This code is called as machine understandable code. Now in this process, the block diagram specifies that what are the program statement which is written by the user, that is statements are to be written. A program is to be written with the set of program instruction. Program is nothing but set of instructions, that is saved in a file .c. If it is a C program, .c file that can be stored. If it is a C++, .cpp, etc. This type of programs are stored. First, initially, how many phases are there? We look into this one. This is the first phase of the compiler, that is called as Lexical Analyzer. And the second one is Syntax Analyzer. And third one is Semantic Analyzer. Fourth one is Intermediate Code Generator. Fifth one is Code Optimizer. And sixth one is Code Generator. See here in this concept, that is a lexical analyzer, first and foremost phase of the compiler. Whatever the source program is written, that is given as input to the lexical analyzer phase. It is called as phases. Total how many phases? 6 phases. The first phase is called as lexical analyzer phase. First phase is called as lexical analyzer. For this lexical analyzer, it takes some input. Every phase takes some input and delivers some output. Each phase, all the phases carries input, and then input accept, and then deliver some, produces the corresponding output. So here in first phase, lexical analyzer phase, accepting the input, that is here input is the source program. Source program contains list of all statements, instruction formats, that is to be written in any one of the non-programming language. That is to be taken as input, and then it generates into the tokens. Generates into the output is token. So we are going to see that each one by one phase with an example separately. First, let us know in the phase of compilation process, that is it is called as block diagram after compiler. The source program is to be converted into machine understandable code with the help of the 6 phases: lexical analyzer phase, syntax analyzer phase, semantic analyzer phase, intermediate code generator, code optimizer, and code generator. At the same time, let's say if you observe, the symbol table management is available, and also you can find that right side error handling mechanism is available. So while taking the input and producing the output for each of the phases, it separately uses a symbol table. Each phase uses a symbol table mechanism. For example, lexical analyzer, in order to store some identifiers, it uses symbol table. Like that, syntax analysis, each and every phase is going to use separately a symbol table. At the same time, while producing output, if any of the errors are identified through the symbol table, through the error handler, it displays error handler. So what happens whenever errors are available, it is to be rectified by the user, and error, whenever the errors are encountered, automatically it recognizes and show that corresponding output. What is the output that is generated without errors? Errors are not available, errors are not there, then we can say that the the corresponding phase is successful. So the error handler is the mechanism in which whenever any of the phase, while for example lexical analysis separating tokens, find any of the errors, it reports to the error handler. Similarly, syntactic analysis, while delivering this output, in between taking the input of this one and produces. So here the important main point from this compilation process is whatever the output that is generated by the previous phase can take as input to the next phase. So for example, here lexical analyzer, what is the output that is generated? The output is taken as input to the second one. And similarly for second phase, syntax analyzer takes the input that is delivered from the output of lexical analyzer, and this output is taken input and then process, then release some output to the next phase of the compilation. The next phase of the compilation is semantic analyzer. Semantic analyzer accepts that output as input and then delivers some other output to the intermediate code generator. Once again, intermediate code generator accepts the delivered output to the input of this intermediate code generator and then code on. Like that, this lexical analyzer produce the output. This output given as input to the syntax analyzer. And syntax analyzer takes this output and then generates semantic analyzer. So like that, the output produced by each of the previous phase can be accepted as input to the next phase of the compilation and then generates a new output, and finally code generator delivers. Yeah. So this is the process. Then we will discuss. We are going to give the brief definition as well as example about this compilation of each of the phases. So first, initially, one more important concept here about the compilation. It is divided into two parts. That means some of the phases are to be worked at front end side and some of the phases are at the back end side. That means we already know that lexical analyzer phase, it is also called as scanner, another name for lexical analysis. Syntax analysis, another name, it is also called as parser. And third phase is semantic analysis. Fourth phase is intermediate code generator, and fifth phase is code optimizer and code generator. Here, why it is separated as front end, back end? Because the code that is generated released for the first initial 4 phases, that means after intermediate code, the code that is delivered, it is the suitable, that is machine independent code, that code is to be processed and sent to the optimization and then generation, what is that? Platform dependent code, that is which is to be run across in the target mission, which is where the execution takes place. So the separation is required for some of the first four phases, and at the same time the running of the phases, while running the error handler reporting errors for that corresponding phase, and entries of the symbol table are to be mentioned for the symbol table. Only the difference between the previous diagram and this diagram is, so here the compilation takes place with the source language as input and target language as the machine code. Only the knowing that these four phases are to be as one unit and these two phases are one unit. These four phases are to be called as front end of the mission, and these two work together as a back end of the thing. So we know that the deliver, that is the what is the uh, output that is produced. Here also we observe that in the initial, that is tokens are to be delivered. This tokens is called as output. This tokens is to be delivered as output. Whereas in the syntax analysis, that is also called as parse. Here the output is parse trees. Here the output is parse trees. And third one, semantic analysis. It is producing abstract syntax trees. And then fourth, that is the code that is generated here, output is intermediate code. And then the optimized intermediate language is to be generated by this optimized code. And then finally target language, that is mission code, is to be delivered in the mission code, so that the user corresponding program gives the result to the user after a successful compilation to the process. While running, any entries are there, it is to be mentioned in the symbol table, so that the references, address reference is easily resolved, and the corresponding variables is mapped to that, and the reference can be easily checked and retrieved the corresponding things very easily. So that's why symbol table entries are required. We will discuss this topic once again when our symbol table as a separate topic, and handler also what type of errors are to be generated as a separate topic. Now we'll move into the first phase of the, that is phase of the compiler. So we now have seen the how the compiler is separated the phases as a front end and then as a back end. So the phases are same, that is initial from all six phases. Only the difference is here the four phases are to, first four phases are to be as front end phases, and the next two phases are back end phases. First four phases are lexical analysis, syntax analysis, semantic analysis, intermediate code generator, that is as front end. And what are the next two phases, that is back end, code optimization and code generation. Now let us see what the difference of the compilation process in this one, how it can be operated. First, what is meant by initially, we are saying that it is a syntax lexical analyzer phase, syntax analyzer phase, like that. So what is meant by a phase definition? So here we are going to define a phase is nothing but it is an interrelated data items, interrelated thing that is to be taken initially as the form of input. Interrelated in the sense one phase gives the input and produce, one phase gives some input and produces output. So that's why and this output once again given as input to the next phase, and then this phase gives output, and then this phase gives output. But here the output once again given to the next third phase of the compilation. So here what happens, the program conversion from source language to machine code, the phase, each phase is to be involved with the second phase, again second phase output involved with the third phase involved with the fourth phase. Like that, it is called as interrelated operation. From source program is represented one form of representation and produces a different representation. That means output, what is the representation here? Input representation is some, for example, in case of lexical analysis, the input representation is in the form of instructions. that is source program statements, and what is the output, that is tokens. So the representation what is the taken in the source program is one, and getting the output is one represented. Similarly, for example, in the next phase of the compilation, this is the lexical analyzer phase, and syntax analyzer phase. The input that is to be processed is tokens, and the output that is generated is syntax trees, parse trees, or syntax trees, or parse trees. So here the phases involved is the interaction between one phase to another phase, among all two phases together involved, and the interrelation of these phases. Why? Because the input representation one form, and giving the output in another representation, and this output is given as input to that second phase. That's why it is interrelated. So there are total 6 phases. Each phase is involved with different notations and with formats also. We are going to see that how the input is to be represented. First phase of the compilation, that is phases of a compiler. First phase is called as a lexical analyzer, that is also called as scanner. So this is another term which is called, that means what is a scanning or what is a lexical analyzer, and that is another name which is given. That is the first statement. Scanning means we already know it is a reading things from left to right. That means, for example, in the source program, different type of that program is to be written with instructions or statement by statement. Generally, we will write a C program or any other program with first statement, second one, like that. Statement wise, we are going to write. Each statement wise, the program is to be given as input, and lexical analyzer will going to read the entire code from starting from first line to last line, character by character, left to right. So here character by character means the first character and then second character, like that, character by character, and then divide into some tokens. For example, here suppose, for example, if you write a C program, void main if you write. So first, initially the first statement it is to be there. So it is scanner will start position at this place V, and then read second character as O, and then read third character as I, and read the fourth character as D. So here the after that space. So whenever space is identified, it stops the 2 pointers, and this is a buffering mechanism. We'll discuss how the buffering takes place. So at this point, what happens? The space occurs, then 2 pointers are to be taken place at the main M character, and then the word is released. So this word is called as lexeme or tokens. This is called one identified. This one token is identified. This is called as token or lexeme. Like this, it identifies and several types of constants, result words, identifiers, and sometimes whenever we are going to write a program with some comments, a hash with that is a /* followed by list of comments. That means, for example, this function is used to add the two numbers, and we are going to close the quotation. That means this is the programmatical instruction comment, but not executed throughout. So that's why this type of things are to be ignored by the lexical analyzer phase. So some of the things which are considered into the case, that is all programmatic statements, and ignore the comments. That means these are not required for result of the program. So only for reader to know that what is the functionality or the function result, that for that case we are going to write that one as a user reading purpose. But the compiler point of view, lexical analyzer, only the executed statement, that is actual requirement, that is to be read and then to be. So while implementing this lexical analyzer process, that is scanning character, it follows some approach. This approach to identify that lexeme, the tokens that is to be generated, that is with a pair notation. In the pair notation, it is written as angular bracket, token name, followed by attribute value. and then close with the angular. So these two things are to be written inside an angular bracket. So token name in the sense that is the one component, attribute value is the another component. That means say it is a first component and the second component. First component means what is the symbol to be used, what is the abstract symbol that is to be used, and second one means entry of the symbol table. Suppose if I write it is A equal to B plus C. Suppose for example if I write A equal to B plus C, so compiler, that is compiler initially the statement 1 starts given input to the lexical analyzer. So input processing, while processing this scanning from left to right, so initially A is identified. So whenever it is identified with A, then the corresponding the attribute value and token name is to be written as the output of this. That means it identifies that as a first identifier 1 comma 1. So this is the like this it follows a syntax notation, syntax procedure, syntax of the that is token releasing with one valid format. Token releases with one valid format, that is angular brackets, two components. First one is the attribute that is to be specified, if it is a variable or keyword, what is this, like that. And second one is what is the value of that attribute. That means it is the symbol label entry, it is the first or second or third, that is to be mentioned clearly in case of that node. So in this way we will see the example how the lexical analyzer. For example, if you consider this statement, this is one of the one program statement, position equal to initial plus rate star 60. So whenever this statement, this is the program statement which is available in the source program. For example, this is the one of the statement which is available in the source program, and this is this source program has given input to the phase that is called as lexical analyzer, and then it scans and then produce tokens. This is the actual scenario of this lexical analyzer process. So the programmatic statement is position equal to initial plus rate star. We discussed about the token value where it is to be framed in the as a syntax manner, token. So to release the tokens, first thing is the position. It reads that position is 1, and it is corresponding token is generated. What token? Token contains angular bracket, attribute name and value. What is the attribute here? It is so here identifier can be written short as ID. We are going to write that one as identifier short, we are writing as identifier. We already know that identifier is nothing but a variable which we are declaring in the general notation to represent a variable in the programming languages. So which is mapped to the corresponding token. Next second one, value 1. Why? Because it is the first identifier. The first identifier to be that is to be mapped into the corresponding entry in the symbol table. And then the equal to is mapped to the corresponding token, that is angular bracket equal to only. So this is an operator that is assignment. So that this kind of thing mapped to this one. And second, initial, after this one initial, this is the one more identifier. So that's why we have given a token value is ID comma 2. Why? Because already position is given identifier 1. First time it is identifier, and this is the second identifier. So that's why the token that is generated is ID comma 2. And next plus is plus symbol. So that is mapped to a token corresponding token plus. And next the identifier is rate. So this token lexium, that is to be mapped to the third identifier as third identifier. And then star, here star is mapped to the angular bracket, that is star. And then 60, it is a numeral constant which is mapped to a corresponding token 60. So like that each and every lexium is to be able to find out and then releases with the corresponding token structure. Here syntax of token, that is token name with that one corresponding. Here operators semicolon, it is also mapped to the corresponding token. Like this, the first phase of the compiler, it is called as lexical analyzer phase. First phase of the compiler, it is the as simple as that. One takes the accepting all program statements, and each statement character by character reading, and then maps into corresponding token structure and generate a stream of tokens called lexemes. So in this way, this one generates, and the final output for the corresponding statement. This is the output. That is the what is the input? Program statement. This is the input which is passed to the lexical analyzer. Lexical analyzer. This is the lexical analyzer phase, that is called as first phase of the compiler, and generates output. What is the output it is generated? That is called as stream of tokens. Tokens are lexemes. This is called as tokens or lexemes. Here in this case, we seen that the token section identifier 1, and then equal to is mapped to one separate token, initial is mapped to the second identifier, and plus is mapped to separate token, and rate as third identifier, and star as a separate token, 60 numeral is a separate token, and semicolon as a separate. Like that, each and every individual character by character it will read and produces an corresponding identifiers, operators, and everything is recognize that the corresponding generation of token generated, and then this output is sent to the second phase, next phase of the compiler, that is called as syntax analyzer. The first phase of the output can be sent to the next as input to the second phase of the compiler. So we have seen that lexical analyzer compiler is simply generating a token mechanism, list of tokens. All these tokens can be given as input to the second phase of the compilation process. So what is the second phase of the compiler? That is syntax analyzer. It is also called as parser. Another name for syntax analyzer is parser. Why? Because it generates the output as parse trees. So it is called as parser. And lexical analyzer, it is called as scanner. Why? Because it is scanning each and every character from left to right. So that's why character by character and releasing the things. So that's why it is also called as scanner. And syntax analyzer, it is also called as parser. And here, what is the it is also called as parser or parsing. Another names for given as syntax analyzer. What is the output that is generated by lexical analyzer? That is tokens, stream of tokens. That output is to be given to the source language. That is from it output is generated from the source language. And so from source language we are getting the tokens in the first phase. And in the second phase of the compiler, that is syntax analyzer, the input that is generated, that is tokens as input, and output is parse trees. Output is parse trees. So here it creates a tree-like intermediate representation called as parse trees, tree-like structure, and verifies the tokens according to the rules and the syntax correct or not. What are the tokens that is released? Sequence of tokens is verified. The main part of the syntax analyzer is verification of the tokens that is released by the lexical analyzer is correct or not, and then produce the output that is called as parse tree structure. Parse tree output. So we'll see how the parse trees are generated with the help of an example. While developing these parse trees, this is also called as syntax trees, where the nodes, internal nodes, and then external nodes. For example, here internal nodes, all the operators which are to be available can be considered as internal node, and the children of the node is called as the identifiers or corresponding arguments of the operation. For example, a plus b if you consider, then the plus is considered as internal node and children node is a and b. Children node is a and b. So like that, this is called as parse tree or syntax tree. What are the tokens that is generated by this one can be taken. Let's see an example how this with the program statement. Suppose for example previous phase, that is first phase of the compiler, lexical analyzer. Here in lexical analyzer we have seen that identifier 1 equal to identifier 2 plus id3 star 60. So this is that means position equal to initial plus rate star 60. This is the statement, program statement. Then position is generated with the corresponding token, equal to is generated with token, initial is generated with this token, plus is generated with this token, and the rate is generated with the token, and the star is generated with this token, and 60 is generated by this token. So like this the tokens are to be generated, and this is the output of the lexical analyzer. Now in case of syntax analyzer, whatever the code that is generated by the first phase, that is the input, and whatever the parse tree that is generated, this is called as parse tree, and this is called as output that is generated. So it uses a tree structure notation. This tree structure is known as parse tree or syntax tree. Here it uses the internal nodes as operators, and are remaining all other nodes, remaining nodes, that is all other nodes, can be considered as the identifiers to the children of, that means leaf nodes. Then we consider as identifiers. For example, here identifier 1 which is available to the left of equal to, so that's why equal to sign, which is considered as internal node, and then identifier 1 to the left of this one, and what is the right of this equivalent, right side, so entire expression, that is identifier 2 plus. So this entire expression identifier 2 plus id3 star 60, but here the plus the as considered as internal node, and then left of plus identifier 2 is available, so we make it as left child of this one, and the right of the plus sign, it contains identifier 3 star 60, so we can make identifier 3 star 60, but here in identifier 3 star is an operator, so that's why I make a internal node as star, and for star left of this one is id3, and for the star right of the notation is 60, so this is to be placed as right child, and this is to be marked as left child of this one. So like this the syntax analyzer, that is the second phase of the compiler, accept input in the form of tokens and generates the output in the form of tree structure, that is called as parse tree or syntax tree. This is the second phase of the compilation process, where we are going to simply generate a parse tree mechanism. Internally compiler uses this phase and then develop the parse tree. One third phase of the compiler, it is called as semantic analyzer. Third phase, whatever the output that is generated by the previous phase, that is syntax analyzer, that phase is to be accept output parse tree taken as input to this semantic analyzer, that is parse tree notation, and then produces a meaningful that is after checking, verifying the type mismatching, operator compatibility, function calling, any arguments mismatch, any declares any variable which is not declared, everything can be verified, and the structure and syntax of that one is valid verified. After checking is completed, then it releases the corresponding abstract syntax. So it verifies the given source program and then checks the semantics of the language. How it will check the means, any suppose you have declared any integer, and then that integer value may not compatible with the corresponding float value. So like that, for example 5 is an integer and division occurs for a floating value, or float value with integer value division, or any other mismatching of the declaration. So for example, if you declare float x equal to 1.2, and float y equal to 1.2 star star z. For example, z, maybe z is declared with some other 20 integer variable. So here we are going to multiply integer value with the 20 with this one while getting the float value. Like that, the corresponding any where it checks the mismatching of the types, integer data type, integer, float, etc., and operand incompatibilities, verifying the operands whether it is matching the correct operand or not. Functions are to be called with an improper arguments. We are going to define a function with some x comma y, and we are going to call with another calling function x comma y comma z. Maybe parameter arguments may be different, not matched. Calling function and called function, and sometimes we are not going to declare a variable integer x, and this x may be used in the further lines of the program. Like this, there are several semantics of the program statements which are to be available, that is to be properly defined and verified, checked thoroughly at this phase of the compilation process. That is the third phase, called as semantic analyzer phase. This is the semantic analyzer phase, where verifies the programmatic statement with the corresponding meaning. Meaning means if it is declared integer value and the result is obtained with the floating value, whether that declaration is a result declaration, both are matched with the corresponding. Like that, verification and checkings will be done before releasing the code to the next phase of the compiler. So this is to be used for the next other phases supplied by this output can be used by the further phases of the compilation. For example, if you observe the code that, so here syntax analyzer, what is the output that is taken? That parse tree. Parse tree, what is this one? This is the previous phase of the compilation. This is the input is given to the semantic analyzer phase. Semantic analyzer phase is a phase which accepts input as parse tree and generated another tree that is called as abstract syntax tree, that is modified or updated the corresponding parse modified tree. So here, if you observe identifier 1, it is checked with the semantics and releases this correct notation, and equal to verified and then releases 1. Similarly, identifier 2 releases with the same notation here. Here also plus this plus token, it is released with the same. Similarly, identifier 3, if you observe here also it results with the correct syntax with this one only. Whereas here if you observe star, same star with the corresponding. But if you observe 60, so here the meaning of 60 is not clear. It is the defined, not clearly defined. That means here is it integer, float, or conversion, which one? So that is to be clarified and given as a notation as into to float as a separate meaning, and then defined with that value. So that into to float to 60, that is to be defined in the case of this syntax analyzer pass. That means that is verified, declared clearly, and given some semantic meaning to that one, and given a modified updated parse tree, that is called abstract syntax tree, is to be delivered by this semantic analyzer. So this is the third phase of the compiler. So it takes then giving the thoroughly checks the semantics of that particular variable declaration, integer values, argument, function calling, so type misjudges. Like that, several attributes mechanisms are there to verify. And in this example, if you see, the identifiers are to be verified, and if it is there is no difference, then it doesn't modify anything. But if any improper definitions are not clear about that conventions, that is to be clarified, and once again releases a modified parse tree mechanism. And this modified updated parse tree, that is the releasing of the abstract syntax tree, can be given as input to the next phase of the compilation process. And what is the fourth phase of the compilation process? That is called as intermediate code generator. That is the fourth. So what is the intermediate code generator? The purpose of intermediate code generator is whatever the code that is delivered by the previous phase, that is semantic analyzer parse tree and takes that input and then releases the code that is whatever the code that is to be released. That code is called as intermediate code. This code that is released called as so parse tree modified updated abstract syntax parse tree that is to be taken as input, that is representation is intermediate code generation input releases the output, releases output. This output it is called as intermediate code. This code is called as intermediate code. This code is called as intermediate. So here the main advantage is the easy to produce, and by using this code we can easily achieve the target mission language code by implementing this. So it is one of the phase which is involved between both analysis phase and synthesis phase. So we already discussed about the second slide of this lecture, where it divided into two things. One is front end and second one is back end, where front end first four phases are to be involved, and back end remaining two phases are involved. See the first four phases, that is the here fourth phase is called as intermediate code generation. This first four phases are called as analysis phase of the compiler, and back end these two phases are called as synthesis phase of the compiler. So this code, whatever the code that is generated, intermediate code, that is the gap bridge between both phases, that is front end and back end, or analysis phase and synthesis phase. This is the code that is to be delivered by the front end and which is used by the back end. So in that way this intermediate, we will see an example how the code is generated for why it is called as intermediate code, and what code it is generated for the parse tree notation previous phase output. So intermediate code generation takes the input as the modified updated parse that is generated by the previous semantic analyzer. So here we know that identifier 1 equal to identifier 2 plus identifier 3 star into float 60, and then this input taken by the intermediate code generator and then releases output. What is the output it is generated? This is the statements. So here first initially it uses temporary variables or temporaries. So these temporaries may be you can use as per your requirement T1, T2, T3, T4 like that, and then result will be finally stored in one of the temporaries. So that is the notation it is followed by the intermediate code generator. For example, here the int to float, that is to be 60 into 2 float of 60, the result is stored in one temporary variable, that is T1, and this into 2 float T1 is multiplied with identifier 3. This T1 multiplied with identifier 3 will get one more result that is stored in another temporary called T2. So this identifier 3 star into 2 float can be stored in a temporary called T2. Once again this T2 can be added with another identifier, that means identifier 2 plus T2. This can be stored in a result that is called as T3, and T3 is assigned with one more identifier, so entire thing can be result with be stored inside one, that is called as ID1. So how many temporaries we have used? T1, T2, T3. Like this, as per your requirement, depends on the program statements. We are going to use these temporaries not to store the result of the corresponding statements. So here internally the identifier 3 star operation getting one temporary, and by applying plus operation we will get one more temporary, and final result has to be stored in one more temporary, that is ID1 contains the total result, that is T3. So in this manner the intermediate code generator is going to release the code at the analysis phase or the first front end of the compilation process. And fifth phase of the compiler is code optimizer. And fifth phase of the compiler is code optimizer. That means whatever the code that is delivered by the intermediate code, that is that using temporaries T1, T2, that code is accepting as input to the code optimizer and then releases an optimized code. Here this is to be considered as one of the optional phase. Why? Because whatever the code that is generated by the intermediate code, that is sufficient, but in order to improve the compilation process, that means two factors are to be considered. One is time and another one is storage. That means what are the statements which are written, that must be optimized. That means so that the space takes very less space. Less space is taken by the program execution, and whenever the program statements are smaller and smaller, automatically the program execution time takes fasterly it executes. So here the in order to run the program faster and in order to take the space of the program is very less space, so based on the constraints we are going to use definitely this optimization phase. There are several techniques are there in order to optimize the code that to become very fast and with takes with less space. The procedure to be available, that is shortly will take the remaining instruction, remaining, that is methods which are to be instructed in the next coming sessions. So here the optimized code is to be developed based on the statements which are available in the previous one. Suppose for example in the output that is produced by this intermediate code ICC, this is the output. This output is taken as input to the code optimizer, and code optimizer delivers the output. What is the output? Here for example, if you see the instruction statement 1, statement 2, statement 3, statement 4, by using these 4 temporaries the code is released. So here the optimizer, the job of optimizer is reduce the number of lines of code, reduce the lines of code, and so that becomes faster and takes the less space to meet the constraints. So that means here T1, it identifies that T1 equal to ID3 plus ID3 star 60. T1 equal to ID3 star 60. That means here the result that is stored in is to be available in this addition. So ID2, what result it is to be ID1. So ID1 equal to ID2 plus what is T1? T1 means ID3 star 60.0. So first important thing is the 60. It is to be directly applied with 60.0. That is first as a first statement, and for that one T1 is to be removed, and that 60.0 is multiplied with the ID3, that is considered as one temporary. This one is taken as T1, and last two statements together considered as one statement. So ID1 is directly implemented with ID2 plus T1 previous statement. So that's why you will get 1, 2 statements instead of 4 statements. The result is same before the, that is previous lines of first 4 lines of code, whatever the output that is generated after optimizing code also, whatever the result is same, output is same. For the 4 line of instruction, output is same as that of these 2 lines of code. But here what happens, the optimizer is going to perform the optimization process by using various methods, techniques, and then it reduces the several lines of code into that shorter lines, so that we are going to able to achieve program running faster and space with limited. So automatically 10 lines with 2 lines, 4 lines with 2 lines, it takes consumes less space in the memory. So the program runs automatically faster with that. But our aim is getting the result output which is the same with the 10 lines of code or 4 lines of code, and this program output is also same with 2 lines of code. So in this way the optimization will be very helpful to the compilation process. Even though it is optional, but it is recommend to use this optimizer phase, so that the program's execution takes place an important role, and we are getting a fruitful benefits for this. Last phase of the compilation process is code generation. So what is the output that is generated by the code optimization, the reduction that is to be simply given as input to the code generation. So this is the final phase of the compiler, and it is that generation of the code, target mission code, and it reduces the length of the mission instruction program which is carried out by using this optimization first. Finally, the output that is called as mission. So here, while delivering this code, target programming code, mission code, some of the memory locations, address, and are declared. Each of the variables can be specified, and that instructions are to be translated into the sequence of mission instructions to perform the same task. So we already know the example. For example, if you take the previous lines of code that is generated by the code optimizer, the 2 lines that is given as input to the code generator, and this code generator accept this input and generate the output. What is the output? Mission. So here the assembly code that is generated by this code generator is here some arithmetic assembly language instruction format, where f it is the f stands for float value. So like add is one instruction, subtract is one more instruction, multiply is one more, like that. These are assembly instructions. So here our 2 line of the statements can be how it can be easily converted. See, for example, here identifier 3 is to be taken as one variable. This identifier 3 can be stored into a register, is a register called say R2. Say for example RT. That means we are going to use an instruction called as load instruction, and what we are going to load into the contents of the memory, that is identifier 3 into the corresponding register R2. And where the second instruction multiply, this is to be used with the corresponding with the numeric where, that is into to float, that is to be written as a separate symbol as hash notation, hash with 60.0, and the register already contains identifier 3 is R2. So both are to be multiplied, and then the result is stored in R2. The result is stored in R2. Now the one more variable that is to be declared, that is to be used, that is identifier 2. This is to be loaded into the memory with the help of a register, another register, that is R1. So identifier 2, the result that is to be available in R1. So previously we are getting some result that is to be available in R2. Now identifier 1 is to be available in one more register, that is R1. So these both registers are to be added by using and plus operation. So that's why this plus operation is to be used with the add instruction. So add, what is to be added? R2 and R1. So source and destination, and the result is stored in once again say another register, that is register R1. So the final result, that is ID2 plus T1, which is stored in some register R1. So that's why this ID1 register R1 contents are to be stored inside an identifier ID1. So finally the result ID1 is the actual final output, the result of the program that is to be displayed to the zone. So in this way, it is a simple instruction format it follows, and then giving a step-by-step notation for each of the notations for the corresponding statements, and then releases the corresponding output so that the machine can understand. So the another example is j of index plus 4 point. So here the program structure we already know. The compilation process starts from first phase of the compiler, lexical analyzer, syntax analyzer phase. So if you see the review of the given review of the first phase of the compilation process, that is here we have taken the statement compilation, that is position equal to initial plus rate star 60. Simple, this statement is to be taken and then generate the tokens. What generate the token. This is the output of the first phase of the compiler. ID1 equal to ID2 plus ID3 star 60 semicolon. And this output is given to the second phase and then generates a parse tree. And verifying the tokens release the parse tree. That is second phase. And in the third phase, it releases one more modified parse tree with the help of checking the semantics and structure meaning of each and everything. And this modified parse tree given to the intermediate code, and this releases a code, and this code is called intermediate code, that is released by the intermediate code generator by using lot of temporaries, that is T1, T2, T3, etc. And this code is passed to the fifth phase of the compiler, that is optimizer phase. Here reduction of the lines of code takes place and then releases a short form of the code, and this code is sent to the code generator phase, and code generator by applying assembly language instruction release the machine code. And by using this, the compiler machine understand the language and then release or generates the output, so that the user can see that the outputs are to be displayed onto the corresponding displaying systems and note down the corresponding. So this is the sixth phase of the compilers. Next we'll in the next session we'll come with the one more example, that is the A of index equal to 4 plus 2. That now as the next we are going to try with all the six phases, that is lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, code generation. All the six phases, how it can be processed with a different programmatic statement with the next session with the one more example. Okay, thank you all of you.
Like, share and subscribe. Hit the bell icon for more updates.